Now there's a really nice analogy looking at iron, okay? And as iron makes a transition from the liquid state, molten state, to the solid state, okay? You take molten iron, and it's completely symmetric in the sense that, you know, iron atoms have a little magnetic moment to them. They're magnetized. But if it's a liquid, then there's no particular alignment of those. And so if you look at the magnetic field inside of a liquid iron, it's not very strong and it doesn't have a particular direction. You know what I'm saying? It's completely randomized. And complete random state like this is completely symmetric, okay? Which is kind of contrary to what you're used to in the artistic sense, right? But in the scientific sense, it's very symmetric in the sense that no matter where you look, in any direction, everything looks the same. It's completely randomized. Everything is randomized. Now, as the iron cools, okay, it starts to become solid, what happens is that suddenly these atoms start to align with each other as they freeze. And you get little regions throughout the iron, we call these magnetic domains, where all of the atoms are aligned and there's a strong magnetic field in a particular direction. Do you know what I'm saying? This is exactly what happens with the Higgs field. In the universe, and when it was young, it was very hot. The potential that was there, okay, for a Higgs field, the scalar field, but it had no particular value. Everything was perfectly uniform. And then as the universe cooled, it froze out. The Higgs value chose randomly a particular strength, and that remains throughout the rest of the history of the universe. So the Higgs field is everywhere. It's not zero, it's there. There's some strength to it. And because it's there, particles develop mass. If it hadn't been there, they wouldn't. Now, to understand how they develop mass, there are other analogies one can use. Effectively, one is that this field that's there now, it actually slows particles down. Some particles, some more than others. And by slowing particles down from the speed of light, you're effectively making them heavy. You can think of gravity, right? And we talk about Einstein gravity and how gravity warps space-time. Well, a planet is just equivalent to a gravitational field that's extremely, extremely concentrated. Whereas away from the planet, it's weaker, okay? So mass can be seen as concentrated field or vice versa. And this is what the Higgs field does. It traps the fields of some particles and concentrates them, effectively making them heavy.